In this video, we'll be looking at solved examples on exponential equations leading to simultaneous equation. And if you have not subscribed to this channel, kindly hit on the subscription button to subscribe so that you'll be the first person to be updated when a new video is being uploaded. Now let's get started. We have this set of examples, and in example 1, it says that solve the simultaneous equation 3 exponent x minus 2 exponent y plus 2, which is equal to 49, and 2 exponent y minus 3 exponent x minus 2 equal to -1. Now when we look at these equations, there is no common base and common exponent, or we can talk of a common base so that we can equate the exponent. In this case, we have to simplify the equation and represent our simplification by a variable so that we can continue with our solution. Now let's put it into practice. Now we have our solution as, so we tackle the first part of the equations. So the first one, we have 3 exponent x minus 2 exponent y plus 2, which is equal to 49. Now with this, 2 exponent y plus 2 is the same thing as 2 exponent y times 2 exponent 2, which means that initially the base were multiplying and they had to add the exponent. So if you have this idea, then it means you have 3 exponent x minus 2 exponent y times 2 exponent 2, which is equal to 49. Now further, we can continue with our solution. You have 3 exponent x minus 2 exponent y times 4, that is 2 exponent 2, giving us 49. So to make it simpler, we have 3 exponent x minus 4 multiplied by 2 exponent y, which is equal to 49. Now let's put this there and label it as equation 1. And we continue with the next one. That's the next equation. And that one, we have 2 exponent y minus 3 exponent x minus 2, which is equal to -1. Now with these two, when we look at 3 exponent x minus 2, it means originally the base were dividing and they had to subtract the exponent. So with this, then we have 2 exponent y minus 3 exponent x divided by 3 exponent 2, which is equal to -1. And we can rewrite this as 2 exponent y minus 3 exponent x divided by 9. And we know that 9 is coming from 3 exponent 2, which is equal to -1. Now we can continue. You have 2 exponent y minus 3 exponent x, all divided by 9, which is equal to -1. Now in this instance, we can see that our LCM here is 9. So multiply 2 by 9, which means you have 9 multiplied by 2 exponent y minus 3, or minus 9 multiplied by 3 exponent x divided by 9, which is equal to 9 multiplied by -1. So we have 9 multiplied by 2 exponent y. Now this 9 cancel that 9, and what is left here is 3 exponent x. So minus 3 exponent x we have here as -9. And we can call this as equation 2. And looking at equation 1 and 2, we can see 2 exponent y in equation 1 and 2 exponent y in equation 2. In the same way, we can see 3 exponent x in equation 1 and 3 exponent x in equation 2. And if that happens, we can represent this common base and exponent we see in these two equations by a preferred variable. And in this instance, we are using a. So better still, we can say let a be equal to 3 exponent x and b be equal to 2 exponent y. So by substitution, then from equation 1, 3 exponent x now is a, so we have a minus 4, and 2 exponent y now is b. which is equal to 49, and we can simplify that. So in simplify, then we are going to get a minus 4b, which is equal to 49. Now let's label this as equation 3. Now we come to the other side, that is from equation 2. From equation 2, 9, we have 9, and 2 exponent y now is b, so multiplied by b, minus 3 exponent x now is a. You have a, which is equal to minus 9, and we can simplify it so that it looks like equation 3, which means minus a will come first, and you have plus 9b, then you have here minus 9, so you can call this as equation 4. Now we have two equations here, so with this, what we can do here is to solve them simultaneously, and we can use simultaneous equation by the elimination procedure. So eliminating this a, then we can write equation 3 first, that is a minus 4b is equal to 49, and we have minus a plus 9b is equal to minus 9. Now we can add these two equations, and when we add, we know that a is going to be 0, so a plus minus a is going to give us 0, and minus 4 plus 9, we are going to get 5, so you have 5b here is equal to 49 minus 9, we get 40, which means when we divide here by 5 and divide here by 5, our b value here is going to be 8. Now this becomes the value of b, but we want to find a as well, so we can substitute the value of b in equation 3. Now by substituting b is equal to 8 into equation 3, then we have equation 3 is known to be a minus 4b is equal to 49. So if b is 8 now, then we have a minus 4 multiplied by 8 is equal to 49. Now we know 4 times 8 is 32, which is equal to 49, and our a value now is equal to 49 plus 32, and at the end our a value here is 81. But remember, we are not looking for a and b, the value of a and b. We are looking for the value of x and y. So we said earlier that we should let a be equal to 3 exponent x, and then we should let b be equal to 2 exponent y. And now if we are saying that a is equal to 81, then it means we have 81 to be equal to 3 exponent x. Now 81 can be expressed as 3 exponent 4, that is 3 times 3 times 3 times 3 is equal to 3 exponent x. Now we can see that the bases are the same, and henceforth we can equate the exponents. So that's s is equal to 4. That's the value of x. Now we found out that the value of b is equal to 8. So we have 8 to be equal to 2 exponent y. And we can express 8 for it to have a base of 2 and then an exponent of 3, which is equal to 2 exponent y. Now that the bases are the same, then we can equate the exponent, and y is equal to 3. So therefore, we can say that x is equal to 4 and y is equal to 3. And y is equal to 3. And this becomes the respective values of x and y. Now let's continue with the next equation. Example says that solve the simultaneous equation given that x and y are both positive integers. We'll be using this question in our solution, so let's take note. solve the simultaneous equations such that x and y are both positive integers. Now, the first equation is 2 exponent 2x plus 5 exponent 2 minus y is equal to 7. And we have here as 5 exponent y minus 2 exponent x plus 2 is equal to negative 3. And with this, we are going to deal with it equation by equation. And since we cannot resolve or express one for them to have the same basis so that we can equate the exponent, you'd have to go by this procedural fluency. And we have the first one as 2 exponent 2 minus x plus 5 exponent 2 minus y is equal to 7. Now with this, 2 exponent 2 minus x means that originally the base were dividing, and we can write them as 2 exponent 2 divided by 2 exponent x plus 5. In the same way, you can write this one 5 exponent 2 divided by 5 exponent y, which is equal to 7. Now with this, 2 exponent 2 can be written as 4, and it's being divided by 2 exponent x plus 5 exponent 2 is 25 divided by 5 exponent y, which is equal to 7. Now with this, we can label this as equation 1. Before we continue, let's deal with the other equation. So let's label this as equation 1. And in the other equation, we have 5 exponent y minus 2x plus 2, which is equal to minus 3. Now with this, we can see that 2 exponent x plus 2 can be written as 2 exponent x times 2 exponent 2. This means that originally the base are the same and they added the exponent, which is equal to minus 3. And then we bring our 5 exponent y, and there is minus here. So for the minus not to confuse us, we can put it in brackets. And then we have 5 exponent y minus now 2 exponent x times 4. That is 2 exponent 2, which is equal to minus 3. Now with this, we can rewrite our step as 5 exponent y minus 4 multiplied by 2 exponent x, which is equal to minus 3. We just rewrote like that. So we can label this as equation 2. Now with this done, we can see from the two equations that there is 5 exponent y and 5 exponent y. There is 2 exponent x and 2 exponent x. So to continue the solution, we can represent this base and exponent by a and b, which means we can say that we should let a be equal to 2 exponent x and b be equal to 5 exponent y. That is 5 exponent y. So by quick substitution, then we can quote from equation 1 that from equation 1, we have 4 out of a now is equal to 2 exponent x, so we have a here, plus 25, and 5 exponent y now is now b, and then it's equal to 7. In the same way, when we come to equation 2, we do that substitution. So we can quote that from equation 2, we know 5 exponent y now is b, and minus 4 multiplied by 2 exponent x now is a, which is equal to minus 3. So with this done, then we can label them as equation 3 and 4 respectively. But before that, we can simplify the equation 3 now under equation 1. That is this one, we can simplify it. So knowing well that with this, the LCM now is AB, which means we have AB multiplied by 4 out of A plus AB. So let's take it back. AB, so you have AB now multiplying 25 out of B, which is equal to 7 multiplied by AB. Now we can see that this A will cancel that A, and this B will cancel this B. So at the end we have 4B plus 25A, which is equal to 7AB. So now we can label this as equation 3, while we label this as equation 4. Now with this ideology, we want to find the value of A and B. We can use the elimination or substitution method. In this case, we are going to use the substitution method, and we quote from equation 4, which means from equation 4 we can make B the subject. So better still, we can say that B is equal to minus 3 plus 4A, which can be further written as B is equal to 4A minus 3. So we can clean the equation 4 here and come and rewrite at this side as equation 4. That is the simplified version. Now if that happens, then we can substitute equation 4 into equation 3. Now if you substitute, then we are going to have 4, that is from equation 3 we have 4B plus 5A, which is equal to 7AB. Now our B now is 4A minus 3, and our A is the same thing as A, which is equal to 7A, and we know B value now to be 4A minus 3. Now when 4 multiplies 4, we get 16, so that is 16A minus 4 times 3 gives us 12 plus 25, which is equal to, now when 7 multiplies 4, we get 28, and so we have 28 here, 28A squared, that is A times A, and we have here as minus 21A. Now we can group like terms because we can see a quadratic equation appearing here, which means we can send everything here to the right hand side, then we equate to 0. So you have 28A squared minus 21A, you have minus 16A, and we have plus 12, and minus 25 is equal to 0. So we have 28A squared, now minus 21 and minus 16 is going to give us minus 37. But remember, it was 25A, and then we omitted A here, which means there should be an A here, and then there should be 25A. So if that's the case, we can bring the minus 25A, and then we have our 12 here, it's equal to 0. Now we can further simplify, and we have 28A squared minus 37. Now, so this is how we take it. Minus 37 minus 25 is going to give us minus 62A. So we have minus 62A here, and then we have plus 12, which is equal to 0. And this is a quadratic equation, and so when we factorize with the help of our calculator and other procedures, we are going to get our factorized terms as A minus 2, and then you have here as 14A minus 3. But better still, we can divide both sides of the equation, or divide through by the equation by 2, and that we are going to get the reduced form. The reduced form to be 14A squared minus 31 plus 6, and at the end we are going to get the same factors, so which is equal to 0. Now we can find A, by equating the factor a minus 2 to be equal to 0, and we have a here to be 2. In the same way, when 14a minus 3 is equal to 0, then 14a is equal to 3, which means our a value now is equal to 3 out of 14. Now, the only value for a now is 2, because from the beginning of the question, we said that x and y must be a positive integer. So if a is giving us 13 out of 4, which is 13 out of 14, which leads to decimal, then it may also end up giving the value of x a decimal, and so you have to disregard a to be equal to 13 out of 14. So we are not going to use 13 out of 14 in our calculation anymore because of the condition given the question. So this speaks to us that whenever we have a question, you have to read to understand the question before we tackle the question. Now we are going to use the value of a in the rest of our calculation. Now, in getting the value of b, we said that from equation 4, that is, we can quote that from equation 4, we said that b is equal to 4a minus 3. That was from equation 4. And now, if we have a to be 2, then our b now is equal to 4 multiplied by 2 minus 3, which means at the end we are going to get 5. That is 4 times 2 is 8 minus 3 is 5. So this becomes the value of b. Now we are not interested in finding a and b, but rather the value of x and y. And then from the beginning, we said that we should let a, but we said we should let a be equal to 2 exponent x and b to be equal to 5 exponent y. So now if we have our a value now to be 2, so if our a value now is 2, then getting our x now becomes 2 to be equal to 2 exponent x, and 2 is the same as 2 exponent 1. I have here 2 exponent x. Now we can see that the bases are the same, so therefore x is equal to 1. In the same way, when we come here, we have our b value to be 5. So if b is equal to 5 now, then our 5 is equal to 5 exponent y, and this 5 has an exponent of 1, which means our y now is equal to 1. So that is y is equal to 1. So let's take it back. Our y is equal to 1. So now we can conclude that x is equal to 1 and y is also equal to 1. And this becomes the value of x and y. Now to the last question, that's the most interesting and trickiest, but with us we are going to sail through. Now let's check the last question. In question 3, that's the last one, it says that solve the simultaneous equation 3 exponent x minus 2 exponent y plus 2, which is equal to 10, and 2 exponent y minus 3 exponent x minus 2, which is equal to 2, giving your answer correct to 4 decimal places. So if that happens, and we can write our solution as we are going to deal with equation by equation. So the first one, we have 3 exponent x minus 2 exponent y plus 2, and with this is equal to 10. Now this communicates to us that originally 2 exponent y plus 2 was 2 exponent y times 2 exponent 2. We have 10, and then we have our minus and 3 exponent x. Now, not to confuse us, we can put this in brackets. Now at this point, we know 3 exponent x is going to be maintained, and 2 exponent 2 is the same as 4, which means 4 now is going to multiply 2 exponent y, and we have 10 here. And this is the simplified version of this. So we can label this one as equation 1. Now we continue and we deal with the other equation. And the other equation, we're given 2 exponent y minus 3 exponent x minus 2, which is equal to 2. And with this one, we can see that 3 exponent x minus 2 was 3 exponent x divided by 3 exponent 2. which is equal to 2, and then 2 exponent y was here. Now with this, we can see that we can rewrite this one as 2 exponent y minus 3 exponent x divided by, this is the division sign, and 3 exponent 2 is the same as 9, which is equal to 2. Now we have an LCM, so we multiply through by the equation, and you have 9 multiplied by 2 exponent y minus 9 multiplied by 3 exponent x out of 9. We have here 9 multiplied by 2. And so at the end, we are going to have 9 multiplied by 2 exponent y minus this 9 cancel that 9, so you have 3 exponent x, which is equal to 18. So you can label this as equation 2. Now comparing equation 1 and 2, you can see that there is 3 exponent x and 2 exponent y in the two equations, which means we can represent this 3 exponent x and 2 exponent y by any variable. So in this case, we are saying let a be equal to 3 exponent x and b be equal to 2 exponent y. Now if that happens, we do quick substitution, and we can quote from equation 1 that from equation 1 we have, now 3 exponent s is now a, so we have a, and minus 4 continues, and 2 exponent y now is now b, which means we can write it as 4b is equal to 10. And then we can label this as equation 3. In the same way, when we come here, that is from equation 2, we know that from equation 2, we have 9 already here, and 2 exponent y is known to be b, so that is 9b, minus 3 exponent x is known to be a, which is equal to 18. So we label this as equation 4. That is that. So beautifully written. Now we are going to use the method of elimination to find the value of a and b. Now if that happens, it means that we can rewrite equation 4 as minus a plus 9b, which is equal to 18. It's the same thing, we just change their positions. So now by the method of elimination, now we can find the value of a and b as, we have a minus 4b is equal to 10, and we have here as minus a plus 9b, which is equal to 18. Now with this, we can add these two, and when we add, we know a minus a is going to give us 0, and minus 4 plus 9b, we are going to get minus, that is positive 5b, which is equal to 10 plus 18 is going to give us 28. Now with this, we find the value of b by dividing both sides by the coefficient of b, that is 5. So we have 5 here, we have 5 here, which means this 5 is going to cancel that 5, and b is equal to 28 out of b. Now we can find the value of a by substituting the value of b in any of the equations, and we can choose equation 1. So from b is equal to 28 out of 5, then our a value now is equal to 4b, and b now is what, 28 out of 5, which is equal to 10. Now if that happens, when we simplify all this, then we are going to get 11 out of 5, which means a minus 11 out of 112 out of 5. We have 10 here, so it means our a now, this is a, and it's not 9, so it's a. So a is equal to 10 plus 112 out of 5, and at the end, our a value is now 162 divided by 5. Now this becomes the value of a, and now we have the value of b as 20 out of 5 and a as 162 out of 5. Now we want to find the value of x and y and not a and b. Remember initially we said that we should let a be equal to 3 exponent x and b to be equal to 2 exponent y. So now if you are saying that a is equal to 162 out of 5, that means 162 out of 5 should be equal to 3 exponent x. Now this is a fraction and we cannot express this fraction for it to have a base of 3 and then an exponent. So what you have to come in mind is to apply logarithm to both sides. Now that's the common logarithm. So we have logarithm of 162 out of 5 to the base 10. That's the common logarithm. And then we apply the same logarithm of the base 10 to this. Now if that continues, then we find the value of x by sending the exponent to become a coefficient at the logarithm of the left hand side, the right hand side of the equation, which means we have logarithm of 162 out of 5 to the base 10 now be equal to x logarithm of 3 to the base 10. So at this instance, we divide here by the coefficient of x, that is log 3 base 10. Now we have log 3 base 10. And so this cancels that. Now the only value for x now is x is equal to logarithm of 162 out of 5 to the base 10 and logarithm of 3 to the base 10. And to 4 decimal place, our value now becomes 3.16604. This becomes the value of x to 4 decimal place. Now we want to find the value of y as well. Now we can also quote that if you are saying if b is equal to, and the b value was found to be 28 out of 5. Good. So if b is equal to 28 out of 5, and we are saying that initially we said b should be equal to 2 exponent y, and b is now 28 out of 5, then we have 28 out of 5 to be equal to 2 exponent y. So in the same way, we are going to apply logarithm to both sides of the equation, and that's logarithm to the base 10. So logarithm of 28 out of 5 to the base 10 will be equal to logarithm of 2 to the base y, logarithm of 2 to the exponent y and the base of 10. In this case, we can rewrite the right hand side of the equation as y logarithm of 2 to the base 10 by sending the exponent to the other side of the logarithm to become the coefficient, which means we have logarithm of 28 out of 5 to the base 10. Now at this instance, we divide here by logarithm of 2 to the base 10 and here by logarithm of 2 to the base 10. Now we can see that this logarithm is going to cancel that logarithm, and we have y here, which means y is equal to logarithm of 28 divided by 5 to the base 10 divided by logarithm of 2 to the base 10. And when we punch this on our calculator to 4 decimal place, we are going to get the value of y to be 2.4854. And this becomes the respective values of x and y. So you can conclude by saying that therefore x is equal to 3.166. Alright, so 3.604, and we have y to be equal to 2.4854. So this becomes the values of x and y. And so this ends today's video. Thanks for watching. Kindly like, comment, subscribe, and share. This is Bakumat, thinking beyond infinity.